Hello, everyone. I welcome you all to this 30 days masterclass series on electric vehicle design. Today is day 24. We are going to discuss about microcontroller for EV applications. I welcome you everyone here, and I welcome yes Ramadurai, Krishna, Aditya, Suraj, Dashini, Yogendra, Krishnanand, Karthik. Very good evening, everyone here. Lavi Shiny, Deepak, warm welcome participants. Happy Engineers Day, everyone here. Yes, warm welcome participants. So I hope you have enjoyed this previous classes. So have you practiced this complete EV simulation? Yes, thank you. Good evening, Nita, Somnath, hi, Omkar, good evening, Vikash, reliable engineers. Very good evening, Praveen, Sheikh Shalim, Narmata, Monish. Very good evening, Vishnu, Nihal, Pranav Kulkarni. Very good evening. Happy Engineers Day, everyone here. So, have you practiced the previous classes? So, can you please comment? Yes, I done. Great. Super, Gautam. Super. I'm really happy to see your answer. Yes. Aditya, please download the previous examples from the LMS portal. Somnath certificate will be provided after the 30-day series. Still one more week there, so please wait. Yes, Karthik, Srikanth. Yes, thank you. Super, Srikanth. Great. Tushar. Super, super. Gupta. Super. Divya. Yes, great. Veg foodie. Today is my first class. See, so you. This is the 30-day series. You should submit 35, 25 classes. Yeah, Mr. Nihal, your point is appreciated. Yes. So about the Pantech, so Pantech is a educational equipments manufacturing company. From Pantech, you can get lab equipments for EEE, ECE, computer science, IT, AI, IoT, robotics related products. And our vision is to help 10 million students to learn the technology in easy way. So far, we have trained about 1.5 lakh students. And you have an announcement. Attendance form will be provided at 7:30 p.m. So please don't forget to submit your attendance form because 25 days is a mandatory, right? And still back you can join in the batch 4 internship. Use this coupon code batch 4 EV. So till 16th September you can join there. Yes, yes. So far, we have completed 24 classes. Sorry, 23 classes. Today is a day 24, and in about these 23 classes, we have completed basics of the vehicle dynamics and MATLAB basics and power calculations, force calculations, and converter designs and motor control design part and then battery part and vehicle modeling, how to design a gear system, braking mechanisms, everything we have designed. And we have completely simulated the vehicle with the drive cycles and powertronic converter and then motor and then vehicle, right? Is it clear? Yes, thank you. So now we are going to concentrate for next 6 classes. We are going to concentrate on hardware systems. So the hardware, how we can develop the hardware. right? So in this one, first you should, if you want to develop any hardware, you should know any one of the microcontroller. So in that aspect, I have developed the curriculum, and day by day we will discuss each and every concepts, right? Okay. So So today we are going to discuss about what is automotive electronics, what is the difference between microcontroller and the microprocessor, how to choose the microcontroller for your applications, and what are all the who are all the top microcontroller manufacturers, and how we can design our own hardware, and similarly where we can start to learn the microcontrollers. So where we can start to learn the microcontrollers and how we can implement the microcontroller programming, right? So all these things I have scheduled to discuss with you. So please keep engaged with entire class, right? Yes, thank you. So if you have any questions about the previous classes before starting the class, so please share. So I will try to give you the answers. Yes, good evening, Suprita. Good evening, Malapati. Good evening, Siva Shankar. Yes, Mudab, Mageshwari. Very good evening, everyone here. Attendance will be provided 7:30 p.m. So can you, if you have any questions about the previous session, so please comment so that we can start concentrate on the hardware part. Yes. Yeah, batch 5 also it's going to be there. That will be a final one. Yes. Good evening. Very good evening. Yes. So let's move. So what is automotive electronics? Is there any masterclass series on solar? Yeah, we are going to launch the masterclass series on solar systems by first week of October. First week of October, we are going to launch it. Great. Thank you, participants. Thanks for your comment. Yes. So, what is automotive electronics? See, actually, the electronic part is going to give you some sophistications, both the vehicle as well as the passengers. So in that aspect, if any electronics, the combination of circuit is going to help you. So that's called automotive electronics. So the main purpose of the automotive electronics is to improve vehicle performance, like efficiency of battery, both the riders and then driver comfort level. And so to achieve these things, many electronic circuits has been used. So initially, the electronic control units is used to manage the engine, that is IC engine. In this automotive electronics, the important parameters, the common parameter, if you take any component, but the important parameter is the temperature, right? So here the temperature may vary, depends the type of applications. See, for example, if you take one microcontroller, right? It's just to take a microcontroller, just visit any one website, like it's an online electronic store. See here, I'm going to take like a TMS 320 F28335 processor, right? So in this processor, actually it's a common processor. So that processor may vary based on the temperature range, right? See here, operating temperature, so the main parameter. So the same one, there are the different type of grades. Yes. So there are different type of grades. Suppose if you are going to use it for your household applications, that is comes under the commercial applications. Similarly, the industrial applications. The industrial applications nothing but in the industry we have to follow the ISO standards, right? So in that case, the temperature variations may high, minus 40 degree to 100 degree Celsius. Whereas in the automotive electronics, in the automotive applications, the minus 40 degree to 125 degree Celsius, because the automotive is not a I mean standalone applications. See, actually here there is a temperature rise due to the vibration, stress, and then pressure. So everything these are the external issues. Similarly, for the defense applications, the defense application, the temperature is a wide bandwidth. So like that, based on the application, you have to choose any one of the, suppose if you are going to choose the one resistor, you have to consider the temperature range. So that resistor, how much temperature can withstand, right? So this is the very first step while you choosing the component. So now, similarly, here if you choose this one, the cost also. Suppose if the very less temperature, then the cost will be very less. Similarly, if the temperature is a wide range, then the cost will be huge. See, for example, for minus 40 degrees Celsius to 80 degrees Celsius. So in that case, if you apply this one, the cost of the item will be, suppose if it is like 1900 rupees, right? Whereas if you take that one, in that case, so if you apply that one, the quality as well as the cost, right? See here, the same device, the cost is, earlier it was 1900, but now based on the temperature variations, the amount is 2400 rupees. So first thing, you have to you have to give the proper temperature variations. Second thing, you have to bear the cost, right? Okay. So like that, you have to develop this one. And next one, in the automotive electronic history, the Volkswagen has first company has introduced the electronics based engine control unit. Okay, so this is the very first one. So nowadays, I mean, everything is a highly sophisticated system. So if you take a motor control, or if you take a infotainment, and then other electronic parts, so everything is, it's not a car, it's a robotic with a wheel. Robots, high-end robot with a wheel, or we can call it as a high-end computer with a wheel. So this is the today's transportation systems. It's work. And in within the vehicle, so there are n number of applications is controlled by the electronic controlling unit or electronics, right? See here, suppose if you take a driver assistance monitoring system, and then instrument cluster, accident recorder, and even data recorder, and auto dimming mirror, so everything is comes up with the electronic circuits. So inside the car, so there are n number of electronic models are there to control the, to ensure that its features. So basic, suppose if you are increasing the number of features in your vehicle, then you have to increase the number of electronic part in the vehicle, right? So according this one, we have to use this, we have to look into this concepts. So now, first, if you want to implement all the features, then you should know what is the embedded systems. Because the before this embedded system, so you have a analog electronics, but with the analog electronics, for small applications, you have to develop a huge size of PCBs. Whereas in the embedded system will help you to reduce the biggest advantage is the size, right? And second thing, accuracy level. So in the analog electronics, the accuracy will not be much, whereas in the digital electronics or embedded systems will give you the high end, highly accurate results, you can get it. So due to these two features, we are moving to the embedded systems. So let us take what is embedded systems. So can you please comment in the comment box what is embedded systems? So what is embedded systems? I'm waiting for your comment. Yes, Sushil, if you attend the 10-day classes, worst case I can give you, we can discuss, uh, not to discuss, actually we can arrange the certificate for 10 days certificate. 10 days most class. Like that I can try, but I'm not sure. I have to ensure with my team. Yes, many functions in a single unit. Great. Hardware interfaced with the software. Great, great. Yes, yes, Mr. Gautam. Yes, super. Yes, many function. Simply, we can call it as a many function with a single unit. So here in the embedded systems, actually the main function is you have to integrate all the functions, and that function is implemented uh, via the software systems, right? So the software is going to work on a particular standalone hardware, so that hardware will take care of all the features. So let us take some applications. So this is the airbag system, which is used in the vehicle systems, right? See here, in the airbag system applications, so these are all the sensors. So that sensor signal is connected to the microcontroller. At the same time, the microcontroller will monitor the vehicle, the the vehicle conditions, right? So whenever the sensor value increases and above the threshold, so immediately the microcontroller will take action. So since it's a airbag system, the airbag will get activated, right? So that decision is taken by the embedded systems. So previously they have used analog circuits to change to identify the threshold value. But here everything is a very simple manner. So circuit again is a common circuit. Whereas in the software systems we can modify the threshold value, and then we can change the features, and then we can change the timing sequences. Everything we can do. Right? So this is very simplest electronic, embedded system application. So like this you can get all the kind of applications. Yes. Is my voice breaking? Can you please comment? Yes. Now is it okay? Now am I audible? Can you please comment? Oh my God. Sorry for this interruption. So now I'm trying to change. Now am I audible? Now is it okay? Okay. Okay. Thank you. Thank you, participants. Thanks. I'm extremely sorry for this disturbances. Okay, right. I will try to manage. Thank you. So now this is the very basic example for the embedded systems. So in this one, first we should understand the basics of the embedded systems, right? And so actually in this in these applications, some of other essential requirements also there. So which means that in this for the airbag system, so it's a basic sensor. It's going to measure the weight. Suppose if you are going to verify the accuracy level, so the accuracy level nothing but your sensor gave you the proper output. So here that sensor data needs to be processed. For a airbag system, it's a very small sensor. Suppose if you are going to measure the speed, so in that case, the resolution. what is the speed range, and then how much accuracy level you are going to get it. So these things and all, to achieve this kind of features, the microcontroller or the embedded system should have a full high, I mean full fledged data as well as that program memory, because in the memory part only we are going to save the parameter, and then whenever we need we can we can get it from the locations, right? So for those applications other essential parts are required, that is called data as well as that program memory. And and if you're taking that data as well as the program memory, so how the programs are going to be fed to the control microcontroller, right? So there are two different instruction sets, that is called the software part. One is called complex instruction set computer, that is CISC, and then RISC, right? So these are the instruction sets. Similarly memory, based on the memory type also we can change the microcontroller. So there are variety of memories are there, so you have to choose it. And similarly, if you are going to feed the application code to in your microcontroller, so the microcontroller will communicate with data as well as that I mean interface, other interface models. So there are two different way of communications. One is called parallel communications and another one is called the serial communications. Actually the common data lines are used to access all the peripherals like a memory or data or input or interface models. So this is the common address lines, at the same time common data lines, whereas the hardware architectures are having the individual dedicated lines. So here we can take a data immediately so that we can reduce the time, right? Suppose if you consider this event, like in your airbag, if your vehicle got accidented, met accident, so in that case, so the airbag system should respond immediately, I mean within a few microseconds, because then only we can save the passenger. So in that case, you have to reduce the operating time. So in that case only we can implement, we can reach the complete features. Otherwise, the features is not a valid one. So in that case, you have to choose all these components based on these methods. And see, the microprocessor will have a basic a CPU. That CPU will have a all the items externally. All the models, nothing but the memory, IO lines, and then programming. So everything will be a externally, whereas in the microcontroller we'll have all these things within this controller itself, so that we can work fast, right? And we can reduce the complex also, right? So that's why basic difference between the microcontroller as well as the microprocessor. See here, how to choose the microcontroller. So here first you should choose the applications. So whether are you going to work on the standalone applications or real-time applications or network applications or mobile applications. Whereas again another type of application is called small-scale embedded systems or medium-scale embedded systems or sophisticated embedded system. So which means that small-scale embedded system nothing but if you are going to automate your house door, so that is automatic door closer or door open. So that is very small embedded systems. Whereas medium scale in the sense if you want to add with the camera for the same applications, that is a medium scale embedded system. Whereas if you want to automate your entire home into the smart home, so that is called sophisticated embedded system. So these are the type of applications. And next one, based on the microcontroller bit as well as the memory and ADC resolutions. See here another important factor is called the ADC resolution. If you want to measure the current or voltage of the motors or any one sensors, so in that situation you should have a high resolution ADC, like a 10 bit or 12 bit or 16 bit ADC you have to implement. Then only we can monitor even high like a millivolt range variations also. right? At the same time, the speed, operating speed of the controller. See again, so far the 300 megahertz operating speed is there. So via this 300 megahertz we can, so this is the physical speed. In the operating speed we can, all the microcontroller will have a watchdog timer. So that using the timer, PLL model, phase lock loop model, using the PLL we can implement, we can double the speed also, right? So that's why if you are going to purchase any micro computer, so there will be a speed always the important factor, and other peripherals. So what all the peripherals are inbuilt, and then whether we have to add the peripherals to achieve these applications, right? So like that we have to choose the microcontroller. So now, once if you choose the microcontroller, then you can go for the component sourcing. So the component sourcing, actually, as of my experience, so keep digikey.com. So in that in that place, you can get all the components with the perfect data sheets. See here, first you should learn how to choose the mega component in the electronic part. At the same time, how to read the data sheet. That is the another changes. Actually, in gate drive or circuit topic, we will discuss about the data sheets, and then how to choose it, what are the parameters we have to monitor or notice. So everything we will discuss on that session. So please keep engaged with the entire classes. Right? So this is the component. So finally, you have to choose the component sourcings. And now, in this, actually for this one, for this airbag system, so first you should identify the ADC value. So whether is it a 10-bit ADC or 12-bit ADC, and then 16-bit ADC. And the next one, the communication channel. So whether the microcontroller has onboard communication model. See, like CAN protocol is available on the controller or not. Right? So these things we have to monitor. And similarly, the speed, operating speed of the controller. And finally, you have to consider the cost. So like that, you have to choose the components, choose the microcontroller. So these are the top 10 manufacturers, microcontroller manufacturers, Renesas and then ST. These two guys are the leading automotive electronics in this world. And similarly, the microchip, TI, analog devices, and then Cypress Semiconductors, Infineon. So just download these presentations from the LMS portal, and try to visit all these websites so that you can understand more about the components and microcontrollers, right? So just for your information, I have used. Participants, the attendance form will be provided, so please don't rush up. And see, actually in the Texas Instruments, actually if you are going to develop work on the power electronic applications, either you can use this, you can choose any two of these guys, like microchips and then Texas Instruments. So this, if you are working with these two company, then you can get easily placed in the power electronic application industry. All right. So now, if you take Texas Instruments, so they are giving you complete solutions for onboard charger. So just visit the ti.com. So there you just search onboard charger reference design, you can get a complete design. And then DC to DC converter, traction inverter, DC charging stations, and then automotive HV, AC, that is the cooling systems. So everything you can get it very quickly. All right. See here, I have added this link. So just to click the link, you can download all the reference designs. So you can use it. So based on the speed, you can choose it. Okay. Right. And the cost comparisons. So initially the cost is very low for the microcontrollers, and then FPGA will have a huge cost. In particular motor control applications and then charging station applications, the company will use both the model, like a DSP as well as the FPGA. And in the single application board, these two model will be integrated. The DSP will give you the high-end calculations, because our system is going to work under the closed loop applications. Whereas the PWM, if you need a n number of PWM, then FPGA IC only can give you n number of PWM. right? Instead, like a 36 PWM, 50 PWM, in the sense you have to go with the FPGA. But at the same time, if you want to calculate the accuracy, like PID methods or other any other closed loop methods, then the DSP processor will give you the perfect solutions. So now you have chosen the controller and then you have chosen the sensors, how to design a board, how to design a target board. So this is the target board which is used in the electric vehicle systems. So if, suppose if you are going to buy any BLDC motor with a drive, so inside the drive, like this board will be there, right? See here, a microcontroller. So this is the one major microcontroller, and other thing with nearby the microcontroller. So this module is called crystal oscillator. So this crystal oscillator only going to decide your controller speed. And similarly, this is the programming unit. So if from the laptop or computer, you can download the application code, and that application code will be fetched to the microcontroller, right? And these are all the additional communication models. And again here, see here via this one. See here, this is the battery cells connector. If you take this board, the battery cells connected with this board, so which means that each cell's voltage as well as the current is connected to the board. So this board will keep on monitor the two parameter, right? So based on the application code, you can implement the BMS algorithm, and then the thermal management algorithm, everything whatever you want. So now we are going to design the board, the similar kind of board. So how we have to choose? First, you have to select the processor packages. Suppose if you are using the DIP packages, then this soldering iron is enough. Suppose if you are using that QFP, that is called quad flat package. So if you are choosing this one, then you have to go with the soldering station. So the first one is the soldering iron, and second one is the soldering station. So because, and sometimes suppose if it is a BGA package, for the BGA pack and then SOC, then you have to go with oven. So generally this kind of equipments will be provided for the assembly house, electronic assembly house industries only we will have. If you are going for the large number of productions, so you have to use this one. And processor selection, while you selecting the microcontroller, you have to always keep verify whether the IDE, that is called integrated development environment software, is available or not, whether is it open source or else whether is it easily programmable, or how we can program the thing. So everything you should know, right? So that is called development tool. Second one, number of IOs, whether the controller has sufficient IOs for your applications or not. Then performance, speed of the thing, and then cost, operating systems. So everything you have to keep in your mind to choose the microcontroller. And after that, hardware design flow. First you have to develop a schematics. From the schematics you have to convert to the layout. Once if you convert the layout, then the PCB manufacturer will give you the board. So for the PCB manufacturer, we have to deliver this board, this software. So this is called CAD design. And once if you deliver this Gerber file to the PCB manufacturer, so he will give you the complete PCB. So now we have to assemble the component over the PCB with the help of assembly house or the electronic house assembly house. So there, generally the electronic assembly house will be highly isolated for the static electronics, EMI, MC issues, right? So this is the while you design the schematics, so you have to concentrate on these things like a power supply design, and then separate designs ground for the ADC, like, and then DAC, because in the microcontroller or DSP there will be two different type of power supplies. One is called power supply for the core, and second one power supply for the peripherals. Suppose if you take a ADC power supply, so the ADC ground as well as the core ground both are two different. So you have to take care of all these things. And then decoupling capacitors, you have to feed wherever it requires, right? And then protection devices also we have to implement. And then layout, while you connect the while you design your layouts. So these points needs to be keep in your mind. So the track size and then length of the track. So generally we have to keep in your mind, right? Suppose if you take this two tracks, see here this track and then this track. For always you should try to route the track with very less travel distance. At the same time, if you are running the track with the positive and the negative with a very closed manner, then there is a chance to cancel the EMI issues, right? So that also you have to keep in your mind. These are some small tips just to take as NSS. And so design complete hardware design flow. So first you have to develop an application code. So that application code will be downloaded to the hardware via the debugger, right? So this debugger will keep on download the hardware application code to the target board. At the same time, whether the code is bug free, like your application code is completely working fine, in the sense we can remove the one, we can go for the protections. Otherwise we have to keep on debug the board via the debugger, right? And see here, this is called the simulations. With the MATLAB we are doing the simulation part. At the same time, whatever we verified the concepts, the same thing we are downloaded to the hardware, that is called evolution, right? So this is called emulation, nothing but the software is directly running with the hardware. At the same time we can take the parameter from the hardware to the software. So this is called the emulator. So this kind of emulator is used to develop the application code. Actually from Pantech you have all the boards comes up with the emulator. So particularly in the FPG as well as the DSP boards. Once if you finish the product, then you can go for the cabinet. So there are, for the cabinet there are two different size or different method. One is called, nowadays due to the 3D printer technology, so straight away you can design the cabinet. So for the prototyping applications you can go for this one. Whereas for the huge number of requirements, so you can go for the CNC cutting. So either a plastic molded or molded based cabinets, or else stainless steel based one, or else wooden based. If you assemble the board, if you connect the board to this test zig, then this board alone will verify whether this board is working or not. So this is simply like we can avoid the huge debugging time, right? And so how okay, so far we have learned about the hardware part. So now how we can start the microcontroller part. So where you have to start? If you want to learn the microcontroller, so first you should start from the how to blink a LED for any one microcontroller. Suppose if you are going to learn the microcontroller like DSP 304011, so in that sense, how to blink a microcontroller from okay, no voice. Sorry for the interruptions. So there is a huge issues. Let me try to manage. Now is it audible? Now am I audible? Now am I audible? Yeah, thank you. See here that this is the test zig. So this zig is going to use for the volume protections like 10K pieces or 20K pieces or 1 lakh pieces per month or something like that. So suppose if you are running, running the protection unit on this speed, you need a test zig, This jig will help you to avoid the testing time. Suppose if we consider this is our final product, so this the blue color board is our final product. So this is called the test zig. So if you connect the board to this zig, so this board will identify whether the board is properly soldered and properly component chosen, and then is there any PCB track issues, everything, power supply issues, everything will be automatically tested with this unit, right? So this is the final part of the hardware development. And now you have, okay, so far we have considered the theoretical part. So now we have to learn the controller, right? Any one of the controllers. So the thumb rule is, if you want to design any applications, you must know any one of the controller. So there are huge number of controllers are there, so you have to choose based on your convenient. So here there are, first one is the 8051 microcontroller, PIC microcontroller, ARM microcontroller, ARM processors, and then Arduino controllers, and then DSPs like a TI DSP, microchip, analog, everything, right? So these are all the microcontrollers. From Pantech you can get these kind of supports. And from programming level, so there are two different one is called script programming and graphical programming. See, the scripting programming, nothing but you have to develop assembly code or C code to download the application. Whereas the graphical programming, from MATLAB Simulink, simply we can call the library blocks, and then we can keep in the applications, we can download it. So this is the graphical programming. So if you want to learn the script programming, so please try to join with our IoT masterclass series, which is going to start coming week. So please try to join in the program, right? Whereas the graphical programming, already we have discussed with how to develop a graphical programming, right? So here just visit this page to learn the Arduino programming as well as that IoT masterclass. If you are interested, you can join there. And so the graphical programming, nothing but in the MATLAB we can take a block, and we can keep in the workspace. If you run the if you click the run button, then we can take a output. So if you take, this is our application code. So this is our final applications. So in this applications, we have to develop a Simulink program to download this one. So let us check one by one. So let us check one by one. I will actually, I have some video. Yes, just a second, let me share. I will share you. So this is a pre-recorded video. Already we took this hardware part. See here, first you have to develop the application code. See, actually this kind of Arduino Arduino controller. See here, the Arduino pin number 9 has been selected. whether the Arduino is connected or not, right? And after that, see here, if it is connected, so you can select, yeah, so device is ready to connect with the MATLAB packages and all everything. And after that, based on the application code, see here the 10 seconds is the duty time, and then pulse width is a 10, I mean not, yeah, 10 percentage. So if you download it, then you can check the hardware whether the hardware is available or not. That PWM we can verify, right? Yeah, see here that LED is blinking. So this LED is the PWM output. So we can either we can check. Yes, see here we can check onboard LED, or else we can use that CRO or DSO to verify the pulse width output. So like that you can generate a pulse width modulation. So not only the PWM applications, you can use it for any applications. You can use it for the any applications. Right, so like that you have to implement all these things. So I will try to give you, due to the mic issues, I am not able to give you the clear voice. Now am I audible? Now am I audible? Okay, so I will do one thing actually. This Arduino demo, I will share you one video. I will share in the WhatsApp group. So try to watch all the classes, how to follow all the things and all. So you can learn very easily. Yes, actually today I problem with my mic, I think so. So let me check. I will try to solve the issue with it tomorrow. Arduino programming, I will share you the recorded classes. So recorded classes by WhatsApp group, as well as that email I will share you tomorrow. So there you can check. Actually, I have developed this recorded classes. So this video, I will give you the complete video. It's a 42 minutes video. So you can use it for your applications. Yes. So now internship option there. So you can use it. Still tomorrow you can join in the internship batch 4 EV. So try to use it. So now you can ask your questions if you have anything. Books for EV, that actually for past 2 days I shared some reference books in EV. So please check it. Yeah, that IoT masterclass is going for the next coming week. So if you are interested, you please join there. Yes. Thank you, participants. Thanks for your valuable time here. So if you have any questions, you please come.